Hello, Gretan. How are you today? I hope you're doing fine. So today we're going to continue our study about dynamic electricity, okay? And we are continue about talking about electric current. And please, if you didn't watch yet, please watch that first about the voltage and about electric current, okay? Because today is the third video, and if you don't understand the previous one, it's going to be very hard for you to understand this one, okay? So in this video specifically, I'm going to talk about resistance. So what is the resistance? Resistance comes from the word resistors that are equipment that transform electrical energy into another form of energy. For example, a toaster. A toaster transforms electrical energy to thermal energy, so to heat the bread. And another example, fan. A fan transforms electrical energy into mechanical energy. So the movement of the fan is mechanical energy. So resistors are this equipment that transform electrical energy into another form of energy. Okay, and then resistance is how much this equipment, these resistors, decrease the flow of energy. Electrical resistance is the ability of a material to hinder the flow of electric current. And the resistance is the force that hinders the flow of the current. Okay, so it likes avoid the current to pass. And the higher the resistance of a material, I'm gonna have less energy for the current to flow. So they are inversely proportional. So the higher the resistance, so if I have a high resistance, I have less energy passing. Okay, so let's imagine if, for example, a street. If I have someone in front of me that doesn't let me pass, less cars will pass. Let's see, there is for example, some guards, they are controlling the number of cars to pass. So not all cars pass and not in the same velocity. It's the same here. Okay, so if I control this flow, so the more I resist, the lower the energy, the lower the current to flow. There is some factors that affect the resistance of a substance to flow. Okay, so we have 4 factors. The first one is the nature. So how is the nature? What this substance is made of? For example, good conductors, so electrical conductors, they allows the energy to pass through it. So they offer less resistance for current to flow. So they have less resistance, more energy is gonna flow. For example, silver, gold, seawater, copper. So all these good electrical, they have less resistance because they let the energy to pass more easily. And the contrary, electrical insulators, they are poor conductors because they do not allow energy to pass through it, okay, or just allow a little bit to pass it. So they have more resistance for current to flow. For example, glass, rubber, plastic, oil, and so on. The second factor is the length, okay? The longer an element or a wire, the greater its resistance for current to flow. So this is logic. For example, if I have I have a long wire, so the wire is long, I have more space for this current to flow. So it's gonna be more space to be resistant, while the short wire has less resistance. So let's see an animation here, so just for you to take a look. So look here in the short wire, the electrons are flowing much faster. Why? Because the length is short, so they have less space to touch it, so there is less chance for resistance to happen. While in a longer one, there is a long way to pass, so they are going slowly because there is more surface of contact, so they go slower and slow because there is more resistance. Okay, so the longer the wire, the higher the resistance. The third factor is the diameter. An element with a very small diameter resists current flow more than an element with a large diameter. So if I have a large diameter, I have more space to pass through. But if I have just a small, I have less space to pass. So it's going to be more hard for me to pass. So a large diameter allows me to pass more volume of energy. And a small one, just a little bit. It's the same as the street. If I have a small, just like, for example, we have 3 lanes, and so we pass a number for, let's say, 100 cars. Okay, so we can pass 3 cars in the same time. But if I close and I have just 1 lane, I have a, let's say, a less smaller diameter. So more cars need to pass through that lane. So it's gonna have a traffic, it's gonna have a congestion. Why? Because there is less space to pass. It's the same here. Okay, I have a small diameter, so I have less space for my electrons to pass, more energy to pass. While in a large one, I have more space, so it resists more. So for diameter, a small diameter resists current more. Okay, so more resistance in a small diameter than in a larger one. And the fourth one is the temperature. A warm element usually resists current flow more than a cold element, okay? Because in the warm, the electrons are more spaced, the atoms are more spaced, so there is more space, so they resist current more than in a cold element. So let's summarize here. I'm gonna put the factor, which one has the higher, which one has the lower resistance. So the nature, remember the nature, the good conductors and the poor conductors. Who has the higher resistance? The poor conductor. So poor conductor resists more for the energy to flow. And the lower resistance, the good conductor has lower resistance. The length, who has high resistance? The longer or the shorter? The longer, so the longer have more resistance, and the shorter has lower resistance. And the diameter, who has the high resistance? The small diameter or the higher diameter? The smaller diameter, and lower resistance, the larger diameter. And the temperature, who has the higher resistance? The warm temperature resists more, and the lower temperature resists less. So lower temperature, lower resistance, the cold, and high resistance, the warm. Okay? So resistance, just to summarize, is the force that hinders the flow of the current. It's symbolized by the letter R, and it's measured by ohms. So this letter here, this Greek letter, that means ohms. 1 ohm is 1 volt per 1 ampere. That's why I told you need to understand what's volt and what's ampere. If you don't know yet, please come back and watch that about the voltage and ampere, and then you come back after, okay? It's going to be much easier for you to understand this video. So 1 ohm is 1 voltage per 1 ampere. It means that a resistance of 1 ohm occurs when a current of 1 ampere passes through a material with a potential difference of 1 volt, okay? So it means that the resistance of 1 ohm, it means that a current of 1 ampere is passing through a material with a potential difference of 1 volt. And putting the letters, R is for resistance, V is for potential difference or voltage, and I is for the current that's measured in amperes. This was established by Ohms, and it's known by Ohm's law, that states that for a given resistance, the potential difference in an electrical circuit is directly proportional to the current intensity. So what does that mean? If I increase my potential difference, if I increase my voltage, I also increase my current intensity, okay? So they are directly proportional. I increase my potential difference, I increase my volts, I increase my current. Okay, so if I put more voltage, I have more current. They are directly proportional. But Ohm's law just applies to conductor and not to insulators or semiconductors. Okay, so Ohm's law, this proportional about the potential difference and current intensity, just applies for conductors, not for insulators or semiconductors. Okay, so let's do some practical exercise according to this formula. Example 1. If a toaster produces 12 ohms of resistance in a 120-volt circuit, what's the amount of current in the circuit? Okay, so let's read. And after we read one time, let's underline and what our main information. So if a toaster produces 12 ohms of resistance in a 120-volt circuit, what is the amount of current? Okay, what's the first step? Make a list. So let's remember the formula. So resistance is equal to voltage over current. So let's make our list here. What do I have? I have here the resistance is 12 ohm. My voltage is 120. And my current, I don't know yet. Okay, so first step, done. Now check the units and convert if necessary. So here, it's in ohm, so it's fine. In voltage, it's volts, it's fine. So my current will be in ampere. Step 3, replacing the formula. So let's write the formula again. Voltage over current. So my resistance is 12, my voltage 120, and my current, I don't know. Last step, simplify and calculate. So I have here 12 equals to 120 E. So I'm gonna do cross multiplication, put 1 here. So 12 times E is 12I, equals to 1 times 120, so 120. Now it's multiply, go over there, dividing. So I is equals to 120 divided by 12. If I divide both, I have, so here is gonna be 10. 10 what? Amperes. So the current is 10 amperes. So what's the amount of current in the circuit? 10 amperes. Okay, pretty easy, right? Let's do the second one. Okay, let's do another example. What's the voltage of a circuit with 50 amperes of current and with 8 ohms of resistance? So I'm gonna highlight. What's the voltage with 50 amperes and 8 ohms? First step, to make a list. So according to the formula, so let's make our list. Resistance, I have, yes, so 8 ohm. Voltage, I don't have. And current, 15 amperes. Step 2, check the units. Resistance in ohms is right. Yes. Voltage, it's gonna be in volts. And my current in amperes is fine, so I don't need to change anything. Step 3, replacing the formula. So let's replace in the formula. Here I have my formula. R equals to V over I. So resistance 8 V I don't have, and I 15. And next step, simplify and calculate. So here I have 8 equals to V over 15. And I'm going to do cross multiplication. So here I'm going to put over 1 times V is V, and 8 times 15. So 8 times 15. So V is going to be 120. 120 what? Volts, because I'm calculating voltage. Okay? Let's read the question again. What's the voltage? So the answer, the voltage is 120 volts. Okay? Let's do another one. How many ohms of resistance must be present in a circuit that has 120 volts and a current of 10 amperes? So let's read again and highlight. How many ohms of resistance, so it's asking me the resistance, must be present in a circuit that has 120 volts and a current of 10 amperes. First step, make a list. So let's go make a list. So resistance, I don't know. Voltage, 120 volts. And current, 10 amperes. Second step, the units. So resistance is going to be in ohm. My voltage is in volts, so it's right. And my current is amperes, so also right. Replacing the formula. So I'm going to write the formula again. R equals to V over I. So I'm going to replace resistance, I don't know, voltage 120, and ampere current 10. And step 4, simplify. So I'm going to write again. So R equals 120 over 10. So if I simplify this, I can cut the 0 with the 0. So my resistance, 12 divided by 1, 12. 12 what? What's the unit of resistance? 12 ohms. So let's read the question again. How many ohms of resistance must be present? The resistance is 12 ohms. Okay? One more. A circuit contains a 1.5 volts battery and a bulb with a resistance of 3 ohms. Calculate the current. So let's read again and highlight. A circuit contains 1.5 volts battery and a bulb with a resistance of 3 ohms. Calculate the current. Okay? So list, go to the formula. So let's go to a list. Resistance 3 ohms, voltage 1.5 volts, and current, I don't know. Step 2, check the units. So resistance in ohms, it's okay. Voltage in volts, it's fine. And my current will be in, So my current will be in amperes. Step 3, replacing the formula. I'm going to write the formula again. So R equals to V over I. Resistance 3, voltage 1.5 over I. And step 4, simplify and calculate. So I'm going to just write again 1.5 over I. And I'm going to simplify. So 3 here, I'm going to put 1. and we're gonna do cross multiplication. 3 times 1, 3 times I, so 3I equals to 1 times 1.5, 1.5. So I is, this is multiplying, goes over there, dividing 1.5 divided by 3. So I is gonna be 0.5 amperes. So going back, calculate the current. So the current is 0.5 amperes. And finally, the last one. A portable CD player uses two 1.5V batteries. If the current in the CD player is 2 amperes, what's the resistance? So let's highlight. A portable CD player is two 1.5 batteries. If the current in the CD player is 2 amperes, what is the resistance? Okay. So make a list according to the formula. Here, resistance, I don't know. Voltage, 1.5 volts. Current is 2 amperes. Step 2, check the units. Resistance will be in ohms. Voltage in volts, so it's right. And amperes in current in amperes, right. 3, replacing the formula. So resistance is V over I. Resistance, I don't know. V 1.5 and current 2. And then simplify and calculate. So resistance 1.5 over 2. So resistance will be 0.75 ohms. Let's read again. So what is the resistance? The resistance is 0.75 ohms. Okay guys, so that's it for today. I hope you enjoyed and thank you so much for watching.